Hi everyone, welcome to my channel. This video is going to be the first part of a series where I will deep dive into blockchain, and this is just an intro video. So, what's blockchain? You might have heard a lot of words like bitcoins, ethereum, NFTs. All these are parts of blockchain. So let's understand what is blockchain. So in technical wise, let's imagine there is a giant record of books that everyone can access, and but no one can tamper it. Like no one can go to, let's say, back to page 1 and edit something. You cannot do that, but everyone can see what's written over there and what is going to be. Anyone have the access to write on that book, but they cannot tamper what have been previously written. So that is like a blockchain in simple word. So blockchain is basically divided into, let's say, three parts. Like for understanding, what are three major components of blockchain. First of all, it is decentralized, meaning no one can like control it. Like there is no central authority. Like let's say bank have control, government have control over bank, so we cannot say that it is decentralized. And government can anytime ban the bank, close it, or change the rules inside the bank. Like you, anyone can block you. Like if the government decide that you cannot use this bank, or they decide to reduce your balance, cut something, cut like take some fee from you without telling you, like that things. You cannot do that in decentralized. Everything is written over there, and there is a ledger which keeps record of everything, whatever the transaction have happened in past, and any kind of applications data or something which are based on blockchain. And the third part is it is very secure. Like it is really hard like near to impossible to crack it, but for the general people, like you cannot like hack it or something like that. There is a way like a civil attack, or there are multiple types of attack on blockchain, but they are require really huge amount of computing power, lots of nodes, and although we will discuss it later. So let's see how the growth of blockchain happened in past year. Like the first blockchain based currency was bitcoin, which we all know. It was first presented in 2008 by Hikashi Nakamoto, something like, I don't remember his name, but he was an anonymous guy and he never revealed about his identity till now. And so in 2008 he presented a white paper named bitcoin, and then in 2009 I guess they made some software like on that paper. And for 2 years the founder was active on pay some in the community. After 2 years he just disappeared. So let's see what was the first blockchain was. So it was a digital currency. It was named bitcoin, and what he did was it streamlined the payment system across borders. Like let's say if you want to send some money from India to USA, you have to give some charges to Indian government and US government also, and it takes a lot of time, for I think something like 1 to 2 days. So bitcoin reduces that time to almost like minutes, like 5 to 10 minutes, whatever the computation power and availability of the blockchain at that time. And also it help in various health. And after that technology, bitcoin laid a foundation for different types of softwares uses case like healthcare system, voting machine. Like if every voting, a lot of time, like people just cry on Twitter, left party, if left party win, right one say like election was rigged. If right party won, then they left one say that election was rigged. If you want to control it, like really secure it, we can use blockchain technology to really secure it from fraudulential, voting system and all that. And there are many applications for blockchain. And blockchain is made of multiple components like cryptography, distributed system, and ledger, and peer-to-peer connection. Like it is not just one technology, there are multiple fields involved in making one blockchain. So one of the most important thing that which the blockchain is based on is distributed system. So let's see what distributed system is. So distributions computing like is like there are, let's say, multiple computers involved in doing something. So let me make it clear in simple words how to say that. Let's say you have an expression or mathematical equation, and it requires really huge computation power, and one computer cannot solve it like by on, like there we have heard like this equation takes, if we solve it on single computer, it will take millions of years to solve that. So we use something like distributed computing. Now it's not real exactly what we use distributed computing for, but let's say that. Then if we combine like thousands of CPU in pair, you know and distribute the task to different computers to solve, like divide divide the problem in sub parts and make it work parallelly. So that is what distributed computing are. So there are multiple computers connected through some form of network like bus system, star, or anything. So blockchain is based on this system. Like uh, we'll discuss it later how it is based on. So distributed system has one problem, like which we call it cap theorem. So cap theorem means cap stand for consistency, availability, and partition tolerance. So consistency means all the data available on each computer should be same at a time. Like at one time, like if in my computer it is 10 rupees, then on other computer, if it is a part of that distributed system, it should show 10 rupees on that system also. And availability, like every computer should be available, like every node of computer should be available all the time. And third is partition tolerance, like the connection between each system should be always available. Like there should not be any faulty connection between the nodes. Like nodes means computer here. So so, so there is a classic problem in distributed computing is cap theorem, which we call like you cannot achieve all these three: consistency, availability, and partition. So but like if you want to achieve consistency, then you have to sacrifice either availability or partition tolerance. So but blockchain solve it. Like in general, you can achieve only 2 out of 3, but in blockchain we achieve all these three. And it is not like blockchain solved it 100%. We have latency, but all these three problems are solved in blockchain. Like that is Kaplan theorem. It was given by a professor at Yale University. His name was Che Abadi, I guess. So he he proposed that either we sacrifice consistency or latency. Like if you are to achieve all these three, then there will be some latency in the system. So let's see how briefly, like how, let's see the history of blockchain, like from where it all started. As I told you that blockchain started in 2008, but the base, the system, the all the parts, like blockchain is, as I've already told you, that it is a collection of lots of things, like lots of technologies: cryptography, distributed computing, peer to peer, digital digital cash, like something like that. So it all started in 1930 by okay, let's see from, let me check it. I guess I don't remember the dates accurately, so I have to check on internet. Okay, theorem. Okay, so in so it all started in 1976, when Daffy Hellman, you know, who proposed a paper like on cryptographic key then in 1978. Then there was a concept of public key cryptography, which we use to derive our addresses, public key, private key on blockchain. Then in 1979 there was a Merkle tree concept by Ralph C. Merkle, where the nodes of blockchain are based on, like, all the blocks on blockchain, like based on, like, they are, how they are verified and all those things. Then in 1980s then came the TCP/IP protocol, which is used in almost everything, I guess, for a lot, not in everything, but whatever we use, like Twitter, Facebook, WhatsApp, basically non-media type things are based on TCP/IP connection. Then there came the blind signature by Davidson, and there was a, like in 1982, there was a problem, like Byzantine general problem, which stated that, like, let's say there is a distributed system, and as I've told you, in distributed system there are lots of uh, nodes, like computers, talking to each other. So for consistency and availability and partition tolerance, as I've told you in cap theorem, let's say a system, like in Byzantine problem there are two things, like one is, if there is a fault tolerance, like fault in connection, and the second is, what if a node is misbehaving, like presenting the wrong data. So Byzantine problem was on this basis, like let's say there is a castle, and it is being attacked by enemy. So there are like 30 to 40 generals in that castle, and each one have to act at the same time to protect it, like there is some defense mechanism going on. So everyone have act to at the same time, like around same time, to make it work. So what if the connection, so the communication between each general have to be, like, available every time, and any malicious general, like what if one or two of general is with enemy. So how would you come up with the solution that the connection is communication between each general should be 100%, and what if any general faulted, then how will how the defense mechanism will be still work perfectly fine. So this was the problem, and many scientists gave their explanation and solutions. So you can read on Google how we can solve it. So after Byzantine problem, then there came lots of things. One of the important was in 1991, in Haber and Stornetta work on tamper-proofing document timestamp. So in 1991, Haber and Stornita scientists work on one of the core feature of the blockchain is tamper proofing timestamp, like what laser is currently based on. Like you cannot change the data which have been previously written. So it was really important work in developing the blockchain. In 1992, Cynthia Dwork and Moni Neor, they presented the proof of work consensus, which is used by Bitcoin nowadays, and I think Ethereum in latest version which they will release, I think from 1 year or 2 year from today, it will not have, but Ethereum I think uses proof of work, but Solana don't use that because it is really inefficient way of verifying the transaction. So in then there came the different, like Bitcoin. There was also a bit gold in 1998. Then there were 1995 there was also a DG cash system, but they had some problems like double spending and other, there were different problems, like it was not really, there weren't any smart contract and all security wise, so it was problem back then. And anonymity was also a problem, like it was not an sorry. After that there came many different, let's not deep dive into that. So it's not like, okay, so blockchain have really some good use cases, like in nowadays there are a lot of things which are being made in using blockchain technology, like decentralized finance. Like you guys, most of guys I think have heard Binance or some other trading sites which facilitate the trading of cryptos, NFTs. I think it is like $1 trillion industry, not trillion, $600 billion industry I think. And there are also some heavy research going on different in cryptography and all those theories, or how can we make Bitcoin more like faster. It is secure but it is really slow and heavy computational, so how to make that faster, less compute. And also it is no they like it government cannot control the blockchain, so lot of government I think would put a blockchain, like made it really into the system. So I think government would want to control some of their like things. So there are some problems with government, like if all the banks, like all the money is converted into, let's say, e-cash, like something like cryptocurrency, then government would not have any control over the currency, and which I think is not good thing. Like people think like, oh, I want this, everything should be transparent and all that, and it should not be controlled by anyone. But in my finance classes in college I've read that if something bad happened in the society, if it is like crypto and everything is mathematically defined, so we cannot control inflation by ourselves. It will keep on going, and after some point uh, rich people will control it. So it is really not that like people's technology. If you have lot of money, like you can control the Bitcoin. Like if you have a lot of money, you can buy a lot of computers and change the tamper with the laser. Like if you create more than 51% of the nodes on that blockchain, you can control that. So that is why some centralization is required in important fields like bank or defense, growth sector of our country. So blockchain is not some miracle like something that happened. It also have some drawbacks like scalability. Is scaling blockchain is a problem, like computational problem, as I've told you. And as it explore as it ex- as it scale, like the it becomes slow and expensive, and this will cost like a lot. It grows like exponentially, the cost of using that. For privacy it is good, but not, if it is not designed really carefully, like some blockchain, if it is not, some smart engineers have, like, we are humans, sometimes we left some vulnerabilities, and that may lead to loss of multi-billion dollars of equity assets and all those things. So there is a risk of privacy. Like in centralized system, if any fraud is detected, it can be, or immediately controlled and something like that. But in blockchain you cannot do anything until unless a new software update roll down. So in conclusion, let's say blockchain is a good thing, but it really need like lot of improvement and smart applications. So